Hello everyone, let's talk about another medium problem on Leetcode today, Leetcode 237, delete node in a linked list. It says that given a singly linked list head, we want to delete a node in it. We are given a node to be deleted, but not the head because we are not given the access to that. So if you see the function or method signature, it's like we are just given the node and they just ask us to delete the node. What it says that all the values in a linked list are unique and it is guaranteed that the given node in the list is not the last node, right? So it's not a tail pointer or anything. It's just the somewhere in the middle. And and it also says that delete the given node. Note that deleting the node, we do not mean removing it from memory. We mean the value of the given node should not exist in the linked list. The number of nodes in linked list should be decreased by 1. All the values before the node and after the node should be in the same order. So let's look at some examples. So this is the given linked list 4519, and in that the given node is 5. So in that case, 5 should be removed from the list. Similarly, when it gives a second example with the same list 4519, the given node is 1. So again, 1 is removed from the list, but note that they are not giving the tail pointer or the 9 or the last node that has to be deleted. So uh, I think this problem is marked as medium, but I think once you look at solution, you will feel it's like an easy problem. But I think the trick is to actually understand what is happening uh, inside the code and also why the deleted node should not be a tail pointer. So let's draw a linked list like we had 4, 5, right, and then 1 and 9. So this is the given linked list, and suppose we have to delete 5, right? So what they state is like this 5 should be removed from the list. But if we are given the pointer next here, we can't do and also it's not a double-ended linked list. Like we don't have previous pointer. If it was a double-ended linked list, what we could have done is like node dot previous dot next is equal to what do you say, current node dot next, right? And node dot uh, next dot previous should have been equal to node what is it? So what is it? Node dot next, yeah, node dot next dot previous should be equal to node dot previous, right? So that would have been easy because we just don't care about I mean, it would have been easier, but it's like a singly linked list, so that means we can only go in the forward direction. So now to delete it, the idea is like what they say is like the current node does not have to be deleted from memory, right? This is the big hint. And also it should not be a tail node. So what we can do is like we can say that whatever is the current node, we can say dot node dot val is equal to node dot next dot val, and we know that next will not be null because it's not a tail pointer, right? And what we can then do is like node dot next dot next, oh sorry, node dot next is equal to node dot next dot next, right? So what it means is like we let me rub this a bit. Yes, so what we can instead do is like when we have the linked list like this 4, 5, 1, 9. So what we will do is like we will copy 1 into and suppose we have to delete 5, right? So in this case we have to delete this. So what we will do is like first set the value here equal to 1, right? So now we have 1 here and instead of 5, and of course now this is the node, right? So we are just replacing the value, but now you notice that there are 2 ones instead of 1. So we will just delete the next one because we have the pointer to this node, not the next one, and this will give us the answer, right? So now now that you have understood the problem, I think you will feel it's easy because it's just one or two lines of code depending on different programming languages. And we can jump into the code here. So what we do, what we have to do is it's the same thing. So we can say that node dot val is equal to node dot next dot val, right? And node dot next is equal to node dot next dot next. And that should do it actually. Let's run the code. Okay, it took a lot of time, but yeah, it's here. And let's run the code now. I think either my internet is slow or there's some issues going on with Leetcode. But let's wait if I've clicked the submit button, but I'm still waiting for the uh, reply from Leetcode. Okay, finally it's done. I think it shows it's very fast, but for some reason it could took a lot of time. I hope you like the solution, and if you do, please do like and subscribe. Also, I have added the code link and the problem link in the video description. Have a nice time.